Good day students, and welcome to the third topic, the third lesson, or if you feel like it, the third septo in the course on biomass for energy. By now, you are well familiar with the most fundamental properties of biomass, and you also have an idea about different ways to turn the raw biomass into a biofuel. The biofuel can be solid, liquid, or gaseous, and it can have properties within very wide limits. One of the things with biomass for energy is that it can be adapted, but there are limits. So, depending on the raw material, one can produce fuels of different qualities suitable for different end users. This part of the course is basically 5 nuggets and aims to give you an idea of the combustion process as such and of how some stationary plants may look. You will also have the briefest introduction to some of the emissions as combustion is concerned. So, why is this lesson focused on combustion? There is actually only one process through which chemically bound energy can be released from a fuel, and that is combustion. So all fuel-bound energy requires a combustion process. As you will see in the rest chains material, there are quite a few industrial processes that require process heat. Just think about cement production, for example, or cooking. One main difference between processes is the temperature level desired, and different fuel qualities and energy carriers will be better or less suited to provide the desired temperatures. As you will see in the BusyPlan handbook, column 4 is dedicated to the processes and the appendices are dedicated to the fuel. Following this lesson, you will be aware of the different demands put on a fuel that is aimed for stationary applications. You will have a very brief idea about how different types of furnaces and boilers may look. You will be aware that there are demands put on the fuel and on the energy carrier by the end process. And you will have a first insight to the environmental impact caused by combustion. You will also have made yourself a computational tool to estimate some of the most important properties of a fuel as combustion is concerned. To be able to follow the nuggets in this septo, it is important that you are perfectly comfortable with the chemistry involved. We use no advanced chemistry in this course, but you must be fully aware of how to use the results from a chemical analysis to set up an empirical formula, and you must be perfectly comfortable with how to balance a general chemical reaction. If you feel in the least insecure with respect to this, then use the Open Learning Initiative course in Chemical Stoichiometry as offered by the Carnegie Mellon University. That course material is very instructive and is available free of charge.